Hello everyone, Namaskar, welcome to Maths Guidance and welcome to the 7th lecture of chapter number 7, that is triangles. And this is going to be the last lecture of this chapter, and this is the Q&A session, question and answer session. We are going to solve some very good questions from different sources, from textbook and from reference books also. So yes, let's start the video and let's solve some questions and let's conclude this chapter. Okay, thank you. So let's start with this question. The question is, prove that the sum of any two sides of a triangle is greater than twice the median drawn to the third side. Okay. So first of all, let's draw the triangle. Let us suppose this is the triangle A, B and C. Alright. Prove that the sum of any two sides, let us write it what we need to prove. To prove sum of any two sides, let us see, AB plus AC is greater than twice the median drawn to the third side. Let us draw the median on this side BC. Alright, like this. Let us name it D. So AD is the median, so it is twice of AD. This is what we have to prove. Now you know median, what is the property of a median? It bisects this side. So this BD and DC. So given is what is given? Given BD equal to DC. Why? Since AD is the median. AD is the median. So you have to know what is the property of a median. Alright. Now we will prove it. Proof. First of all, we will construct something. We will produce this AD to E, to a point E, and then we will join this EC. Alright. Okay. So first of all, we will construction. The construction is produce AD to E such that these two are equal. AD equal to DE, AD equal to DE, and then join EC. Now our procedure will be like this. We will prove that these two triangles ADB and ECDE, these two triangles are congruent. Then let's do it first. So now in triangles ADB and CDE, in triangles ADB and CDE, what we have? This AD equal to DE, AD equal to DE by construction. Okay, by construction. Also this BD equal to CD, BD equal to CD, this is given, property of median. Now this angle will be equal to this angle, these vertically opposite angles. So angle ADB is equal to angle CDE, vertically opposite angles, opposite angle. So what do you see by SAS? This angle, it is here. This side SAS. Alright. So by SAS, triangle ADB is congruent to triangle CDE. ADB and CDE, or rather ADB and EDC, this would be better, because AD and DE are equal, BD and CD are equal, so BD and CD are equal. So by CPCT, what we have? We have AB equal to CE, AB equal to C, the corresponding side, AB equal to CE. Now this we have got AB equal to CE. Now what we will do, AB equal to C, all right. So this, in this triangle ACE, now in triangle ACE, what we can write, that this AC plus CE is greater than AE. We can write AC plus CE is greater than AE, because sum of two sides is always greater than the third side. Sum of two sides, this is a theorem, sum of two sides is greater than the third side. We have seen this theorem, alright, that in a triangle the sum of two sides is always greater than the third side, alright. So this implies AC plus CE. In the place of CE we will write AB, okay. So AC plus AB is greater than AE. See, AE, what we can write, AE twice of AD, because AD equal to DE. So we can write twice of AD. And this is what we have to prove. See, we have to prove AB plus AC is greater than twice AD, or AB plus AC is greater than twice AD. This is proved. So basically we are using this theorem, alright, and the congruency rule, all these things we are using in one problem. So it was a good problem. I hope you understand it. Okay, let's move on. Let's take the next question. It's a small question. So that in a right angle triangle the hypotenuse is the longest side. Okay, we will prove it. First of all, let us draw one right angle triangle like this. A, B and C, right angle at B. Okay, so in right angle triangle ABC, in right angle triangle ABC, we have angle B equal to 90 degree. That means angle A plus angle C is equal to 90 degree. One angle is 90 degree, so rest of the two will add up to 90 degree, because the angle sum property. Okay, so now from these two equations we can draw the inference that angle B is greater than angle A, because angle B is 90 and these two add up to 90, so angle B is always greater than angle A, and angle B is always greater than angle C also. So from this and this, what does we mean? Angle B is greater than angle A, means the opposite sides AC is greater than BC. Why? Because the sides opposite to the larger angle, or side opposite to larger angle is longer. We know this theorem. From here also we can write angle B is greater than angle C. That means AC is greater than, opposite to angle C means AB. So from this, let us take this 3 and this 4. So AC is greater than BC and AC is greater than AB. That means the hypotenuse is the longest side. It means the hypotenuse AC is the longest side. The hypotenuse AC is the longest side. Proved. Alright. So basically we are using the property that sides opposite to the larger angle is longer, this theorem. Alright. Now let's move on to next question. Now let us solve this question. AB and CD are respectively the smallest and longest sides of a quadrilateral ABCD. Okay, so AB is the smallest, CD is the longest. So that angle A is greater than angle C and angle B is greater than angle D. Okay, so first of all, to prove angle A is greater than angle C, we will just join this AC. Let's draw another figure. This is A, this is B, this is C, and this is D. First of all, we will join this side AC. Now in triangle A, B and C, we know this is the smallest side. That means this side is bigger than this. So BC is larger than AB. That means the angle opposite to this BC, that means this angle BAC will be greater than angle opposite to this side, means this angle ACB. Alright, let us take this as 1. Also in triangle ADC. So in triangle ADC, since this is the largest side, so CD is always greater than AD. This implies angle opposite to CD is this one, angle CAD or DAC. So angle CAD is always greater than this angle ACD. Let us suppose this is 2. Now what we will do, we will add these two angles, these two equations, adding equations 1 and 2. So basically we are adding the angles. So angle BAC plus angle CAD, left hand side will be greater than angle ACB plus angle ACD. Now you see angle BAC plus CAD, that means angle A is greater than angle ACB plus ACD, that means angle C. This is what we have to prove, that angle A is greater than angle C. We have proved it. Now to prove that angle B is greater than angle D, we will do a similar construction. Let us do the second part here. The similar construction we will do. Let us suppose this is A, B, C and D. So we will join this BD. Alright. Now in triangle, first of all in triangle BDC. We have this is the longer side. So CD is greater than BC. This implies this angle CBD will be greater than this angle BDC. Okay, we will consider this as 3. Now in triangle ABD, this side will be larger than this. So AD is greater than AB because AB is the smallest side. This implies AD means this angle ABD is greater than this side ADB, angle ADB. So adding 3 and 4, what we get? Adding equations 3 and 4, we get angle CBD plus angle ABD is always greater than angle BDC plus angle ADB. This implies angle BD, what I have written, angle BD, angle CBD, okay, angle CBD plus angle ABD, that means angle B, and this side angle ADB and angle BDC, that means angle D. This is also proved. Angle A is greater than angle C and angle B is greater than angle D. Okay, this is what we had to prove. Angle A is greater than angle C, angle B is greater than angle D. So with two simple constructions and using the theorem that larger sides opposite to the larger side having larger angle and opposite to the larger angle having larger side, we have solved this problem. Okay, I hope this is clear. Now let's move on. Okay, now let's solve this question. It's a lengthy one. triangle ABC and triangle DBC are two isosceles triangles on the same base BC. This is the base ABC, AB and AC are equal, and DBC means DB and DC are equal, and vertices A and D are on the same base, same side of BC. If AD is extended to intersect BC at P, okay, AD is extended to intersect BC at P, so that first of all triangle ABD is congruent to triangle ACD, triangle ABP is congruent to triangle ACP, AP bisects angle A as well as angle D, and AP is the perpendicular bisector of BC. Alright, so let's solve one by one. First of all, so in triangles ABD and ACD, alright, ABD and ACD, ABD and ACD, ABD and so AB equal to AC. First of all, we can write that AB equal to AC. Alright, this is given that the triangles are isosceles. Second one, we can write this AD. AD is common. AD is equal to AD. This is common. Third one, we can write this BD equal to CD. BD equal to CD, because this is also isosceles triangle. It is given. So basically, by SSS rule, we can say that triangle ABD is congruent to triangle ACD. First one is proved. Triangle ABD is congruent to triangle ACD. Alright. Now we have to prove ABP and ACP. ABP and ACP. No problem. But first of all, by CPCT, we can write CPCT. We can equalize this angle, because these two triangles are congruent. So angle BAD equal to CAD. Angle BAD equal to angle CAD, or if you call it BAP, CAP, you can call it angle BAP equal to angle CAP. This is the same thing. Okay. Now we will prove the second one. Second one is in triangles ABP and ACP. Okay, ABP and ACP. So first of all, AB equal to AC. AB equal to AC. It is given. ABP, ACP, and AP equal to AP is common. AP is equal to AP is common. Now we will equal this angle. What we have received here, BAP equal to CAP. Angle BAP equal to angle CAP. We have got from here. So this angle is equal, this side is equal, this side is equal. So by SAS rule, side angle rule, we can say that triangle ABP is congruent to triangle ACP. This is also proved. Now let us do the third one. The third one is AP bisects angle A. This AP bisects angle A as well as angle D. Okay, so AP is bisecting angle A. We have seen from here, because this angle BAP equal to angle CAP. Angle BAP equal to angle CAP. Similarly, in this triangle also, you can say that angle BDP equal to angle CDP. So basically, this AP is bisecting both angle A and angle D. Alright, AP bisects angle A and angle D both, as angle BAP equal to angle CAP, angle BAP equal to CAP, and BDP equal to also CDP, and angle BDP equal to angle CDP. So this is proved also. Now the fourth one is AP is the perpendicular bisector of BC. Now since this is the angle bisector, of these two triangles, so basically this AP will be the perpendicular bisector of this side. This is the property. Alright, so you can directly write that since AP is bisecting angle A and angle D both, so we can say that AP is the perpendicular bisector. AP is the perpendicular bisector of AP is the perpendicular bisector of side BC. All right. So I hope this question is also clear. Let's move on. All right. So let's solve this question. Two sides AB and BC and median AM of one triangle ABC are respectively equal to sides PQ and QR and median PN of triangle PQR. All right. So that triangle ABM is congruent to triangle PQN. Okay. And triangle ABC is congruent to triangle PQR. Okay. We will solve it. So in triangles ABM and PQN. Okay. In triangles ABM and PQN, we can write that AB equal to PQ, it is given, and AM is equal to PN, this is also given. So these two are given. Third one we have to find. Third one we will get from here that BC equal to QR. BC equal to QR, this is given. This is given. BC is equal to QR, it is given. And we know that this is the median, so it will bisect. It is a property of a median, it will bisect the sides. So BM equal to MC, BM equal to MC, and QN is equal to NR, we can write. This is also bisecting, so QN equal to NR, BM equal to MC. Now let us divide this equation by 2. Divide equation 1 by 2. Divide by 2. Equation 1. Okay. So we will get half of BC is equal to half of QR. Half of BC equal to half of QR. But half of BC is BM or MC, you can write. This implies BM is equal to QN, you can write. So these two sides are equal and the third side is also equal. So by SSS congruency, by SSS rule, we can say that triangle ABM is congruent to triangle PQN. Proved. Now by CPCT, ABM is congruent to PQN. By CPCT, this angle B is equal to angle Q. Angle B is equal to angle Q. Now we are going to solve the second part. Alright, second part in triangles ABC and PQR. Now what happens? This ABC and PQR. Okay, this AB equal to PQ, BC equal to QR, this angle is equal to, so SAS, we can solve it. In triangles ABC and PQR, so AB equal to PQ, it is given. BC equal to QR, it is also given, and angle B equal to angle P, this we have proved here. Sorry, angle Q, we have proved here. Angle B equal to angle Q by CPCT, angle B equal to angle Q. So these two triangles are again congruent. So by SAS, side angle side rule, this triangle ABC is congruent to triangle PQR. Proved. All right. So friends, I have solved some 5 questions from this chapter number 7, that is triangles, and I hope that I have touched every nooks and corners of this chapter, and I have solved these problems of throughout the chapter, means of every chapter, of every topic. Although questions are there are lots of questions, but it's not possible to solve all the questions, but it's okay. I have tried to cover all the portions. So let's conclude this chapter here, and let's move on to chapter number 8, that is quadrilaterals, in our next video, in our next lecture. So please stay tuned to my channel and watch all my videos. It will be helpful to you, and we will meet you very soon. Thank you very much.